Hello and welcome to recording 1B on the cosine law for Unit 2, Chapter 2, Trigonometry, Mathematics 2200. We'll be focusing in this recording on proving the cosine law. We'll begin by considering a triangle ABC with the vertices named as shown and the sides named as shown. Now, we want to, in this proof, apply a little bit of Pythagorean theorem and some right triangle trigonometry. However, we do not yet have a guaranteed right triangle. It's just some old right triangle we've drawn. The only way to get a right triangle out of this is to draw the height of the triangle, also known as the altitude. Now I've got two smaller right triangles that I can work with. This side that was originally a full length of A is now shared up into two smaller pieces. So I'll call CD X, which means that this remaining piece must be the full length A minus the X. So now I've got two small right triangles. Let's work with them one at a time. First of all, we hide the left side and work with triangle ADB. That's a right triangle. We can apply the Pythagorean theorem to it, and that would give us A minus X, all squared, plus H squared equals C squared. So you notice we've got A minus X has to be all squared. Now, the only thing we can do with that is multiply A minus X times A minus X using expansion. Many of you would know that as FOIL. So we're expanding the A minus X to get A squared minus 2AX plus X squared plus the original H squared that was already there. Next, we hide the right side triangle and show the left side. And we now have, by the Pythagorean theorem, X squared plus H squared equals B squared. So we'll write that in our proof. Now, to understand the next step, we've got to realize that B squared is equal to X squared plus H squared, which is what we see up here. X squared plus H squared is B squared. So we can replace X squared plus H squared with B squared in step 2. So we've used step 3 to replace X squared plus H squared with B squared. Next, we show, or rather we use a bit of right triangle trigonometry. The cosine of angle C is equal to the adjacent over the hypotenuse, X over B. If we bring this B over to the other side, one way you can do that is cross multiply if you understand that better. But B times the cosine of C is equal to X. So it's just a bit of rearranging in step 5 that we do. Next, we recognize that back in step 4 we had an X right there. So we can replace that X with B cosine C from step 6. So that's what we do in step 7. We replace the X that's in step 4 with the B cosine C in step 6. Now we have the cosine law. C squared equals A squared plus B squared minus 2AB cosine C. All we need to do is reorder the terms a little bit. a squared plus b squared minus 2ab cosine c. Remember, in this term right here, everything is multiplication, so these two brackets here are not necessary. That completes the proof of the cosine law. This diagram and a table to complete the proof are provided in the slides. You should perhaps review this recording once more so you can fill in the steps for yourself. So here's the table that's provided for you in the notes. And in summary, the key idea is that the cosine law can be proven for any triangle and can be applied to find measurements in any type of triangle. Of course, from our previous recording, we realized that the cosine law can only be used when we have the measures of 3 sides or the measures of 2 sides and the included angle, SAS.